I know that this problem is categorized under medium difficulty, but to be very honest, it is a little bit towards the hard side. So I want you to be patient with me and I will try to simplify this problem as much as possible. Hello friends, welcome back to my channel. First, I will explain you the problem statement and we will look at some sample test cases. Going forward, we are gonna form the decision tree and see how we can come up with a recursive and a brute force solution. Going forward, we will apply the memoization technique to arrive at an efficient solution and then also do a dry run of the code so that you can understand and visualize how all of this is actually working in action. Without further ado, let's get started. First of all, let us try to make sure that we are understanding the problem statement correctly. In this problem, you are given a string of integers and you have to tell me the total number of ways it can be decoded. So once you heard the term decode, that means this string has already been encoded, correct? So how was it even encoded in the first place? Well, that information is also provided. What happened is each character in the English alphabet was assigned a number. A is 1, B is 2, C is 3, and it goes on all the way to Z equals to 26, correct? Now think about it. Let us say I had a string like this, AA, and you have to encode it. A maps to 1, correct? So you will map 1 over here, and for the other A also you are gonna write down 1. So good, I was able to encode it. But do you see the problem now? If you try to decode this string, what will happen? Either you can interpret it as 1 and a 1 and that will give you AA. Or you can also interpret it as 11, correct? And once you interpret it as 11, it becomes a K. So you were able to decode this string in two different ways, correct? And that is what you have to tell me. Given a string, you have to tell me in how many different ways you can decode it. So for example, in my first test case, I have the string as 12, right? Now, if I try to decode it, either I can do 1 and then a 2. So this will give me AB, or I can treat this as a single string itself. And then this is gonna give me L as my answer. So I was able to decode it in two different ways. So for the first test case, 2 will be your answer. The problem starts getting trickier when the length of your input string begins to increase. For example, in your second test case, my input length is 5 characters, right? So you can split it up in a lot of different ways, right? And now, if you try to map all of these splits into their characters, you can map 1 to A, 1 to A, and 1 to A. But what about 0, 6? If you look in your key, you never have any number that has a 0 in the beginning. For example, F will be equal to 6 and not 0, 6. So this split actually becomes invalid because you do not have any map for 0, 6. So you will not even consider this split. Similarly, now move on to the next split. Over here I have 1, 11 and then 0, 6 again. Both 1 and 11 are valid, but 0, 6 is not valid. So this entire case becomes invalid. Now move on to the next case. 11 is valid, 10 is valid, and then a 6 is valid. So now, if you will try to map it, they will become K, J, and a F, right? And moving on to a last split, I have 1 that is valid, 1 is valid, 10 is valid, and a 6 is also valid. So when this decodes, it will become A, J, and a F. So you were able to split it in a lot of different ways. But what were the valid decodings? You could only find 2 of them. So for this particular test case, once again 2 will be your answer. This bit is very important, that when you're trying to decode, you can never have a 0 in the beginning. And that is exactly what the third test case tries to rely upon. You are given a string that is 0, 6. Now 0, 6 does not map to any of these numbers. Yes, you can have a 10, you can have a 20, but you cannot have a 0, 1 and a 0, 2 because the single digit 0 does not map to anything. So this test case is actually invalid. This string cannot be decoded. So for this particular test case, 0 will be your answer. So that is what the problem statement is. If you feel that now you have understood it even better, feel free to first try it out. Otherwise, let us dive into the solution. Let us say I have this string in front of me and I ask you, okay, tell me how many ways you can decode it. So first of all, where do you even begin? Even if you have to write a brute force solution, you must have a starting path, right? How do you start to conquer the problem? How do you start to attack it? So try to think what we were doing. So either we can take a single digit or we can take a two digit, right? You can never have three digits because you will not find any mapping. So over here for this particular test case, what I can do is either I can take just one digit at a time, that is the number 1, or I can take two digits at a time, and that is the number 12. So once you do this split, you end up in two different positions. If you take the number 1, then you end up with 22016, and if you take the first two digits, that is gonna end you up with 2016. So this is how we are making a decision at every instance, and this is gonna form our decision tree. So what just happened? I took a single number over here, right? And now for this particular state, once again I have two choices. I can either take a single digit 2 or I can either take both the digits 22, because both of these conditions are valid. 2 also maps to a character, that is B, and 22 will also map to some character. So once again, this scenario now splits up into two conditions. If I pick up a 2, I get 2016. If I pick up 22, I will get a 016. Now notice that once I am at 016, this condition is totally invalid because you can never have a decode that starts at 0. So this will not go ahead. That means this split, it is totally invalid and we can get rid of it. We can now keep moving ahead. I landed at 2016. Once again, I have two choices. Either I take 2 or I take two numbers, that is 20. So once again do the split. And where do I come? Either I will get a 016 or I will be remaining with 16. Once again, 016 is invalid. So this split we should not consider. So let us get rid of it. Look at the split now. I get the number 16. And once again, I have two choices. Either I take just a single number 1 or I take two digits, that is 16. If I take a single digit 1, I land at 6. And if I take both the digits, I get an empty string. This empty string is very essential. If you are able to reach an empty string, that means yes, you were able to decode the entire string because you took care of each of the numbers, right? So this is where you stop. And similarly, for the letter 6, you can make one more decision. You can pick 6 and then you will end up with an empty string once again. So this is also one more valid split, right? So whenever you reach an empty string, that means you were able to make your splits correctly. So just check this path. You do one split with 1, then 2, then 20, then a 1, and then a 6 again. So this is one way to decode. And you can also take 1, then 2, then 20, and then a 16. So this is other way to decode. So you found out two different ways to decode, correct? So up till now, I have two ways, right? But notice, we still have the right part remaining. So we are gonna follow the same approach. Over here, I can either take a 2 or I can take a 20. So this gives me either 016 or it is gonna give me 16. You already know that this case is totally invalid, so I can discard it totally. For the remaining case, I have a 16 over here and I will follow the same approach. I can either take a 1 or I can take a 16. And this will lead me to empty strings subsequently. So I found two more paths. The next path will be 12, then a 20, 1 and then a 6. And the other path will be 12, then a 20 and then a 16. So these are all the four different ways by which I can split this string and it is gonna give me a different decoding. So this particular string can be decoded in four different ways. So basically you have to create this decision tree and how many empty strings do you get, that is your answer. But this is the brute force approach. You are taking a lot of time to arrive at this solution, right? And if you also notice, we are repeating some of our operations. Because notice this entire tree. what happens after we reach 2016? This same situation, we have already solved it over here, right? And we are just repeating it. So somehow we need to memoize all of these results. We need to reuse our results. And if we are able to reuse, then we do not need to perform all of these calculations again and again. And once you figure this out, you know that you have to memoize your results. That means you have to apply dynamic programming. So what we need to do is we need to learn our results and then move ahead. So this was the brute force approach. Now let us try to optimize it and come up with a dynamic approach. So how do you start to come up with an optimal solution? Let us say I have a string that has a total of 8 digits, correct? And what we also do is we maintain a memoization array. That means we are storing all of our results and we want to reuse it. So basically the first location, it will store the total number of ways to decode when the length of your string is just 1. And then we are gonna use it somehow to arrive at the next solution. This position 2 will store the total number of ways to decode when the length of your string is 2. Similarly, you will keep on moving ahead, and then this last location, this is gonna store the total number of ways you can decode when the length of your string is total 8, correct? So let us say that somehow you have found out these values, and I am writing some arbitrary value x over here and then an arbitrary value y over here. It simply means that the total number of ways to decode these 7 digits is y, and the total number of ways to decode all of these 8 digits is x. We are taking this to understand how you want to reuse your previous results. So now what happens? Let us say a 9th digit comes in, correct? When this 9th digit comes in, what you'll want to do? You will want to extend your array, and now we want to fill in this particular position, correct? Once this new digit comes in, it can be decoded in 2 different ways, right? Either you treat it as a single digit. If you're treating it as a single digit, it can be between 1 to 9, correct? It cannot be 0. So you have to check if this new digit that I'm adding, it is even valid or not, right? If it is valid, then the total number of ways are whatever you had up till here and then this new digit, correct? There is one more way by which you can decode it. And that is if you take up the last 2 digits of your new string, correct? And then these 2 new digits, they must be valid as well. It means that they can be between 10 to 26. Less than 10, they will become 09, 08, 07, and they are invalid. More than 26, they cannot be decoded because Z maps to 26. So these last 2 digits should be valid as well. When these last 2 digits are valid, then what are the total number of ways to decode? The total number of ways to decode will be the number of ways you have decoded your last 7 numbers, that is y, plus this new number, if it is valid. So this gives me an equation. If I have to fill up this particular position, that is 9th, I am looking at my previous 2 positions, right? 8 and 7. What do I get basically? I get that ways to decode at the ith location. That will be the ways to decode at I minus 1 if this new single digit is valid, and ways to decode at I minus 2 if the last 2 digits are valid. So basically what I am trying to fill in this particular block, it is dependent on these last 2 values, that is x and y, and they are based on if these 2 new digits that I'm adding, they make up a valid case. So this is how we are going to use memoization. Let us try to take up the same example we had and come up with this approach. Over here, once again, I have my same sample string, and I also have my memoization array that we will try to use. So the first step is that you have to initialize this array. So how do you do that? What do you do about the 0th location? Try to think, what does 0 means? 0 means that the length of input string is 0. If the length of input string is 0, how many ways you can decode it? You can only decode it in one way. That means there won't be any output. If there was no input, there is no output. That is the only way you can decode it. So over here, I can safely write down 1. If you remember, we had a dependency on the last two values. So we also want to initialize this first value as well. So when the length of string is 1, how many ways you can decode it? Try to think. If the number is between 1 to 9, then there is only one way to decode it, correct? But if the first number is 0 itself, then you cannot decode it at all because 0 is an invalid case. So depending upon this first digit, you will populate your memoization array. Since your first number is 1, you can decode it in only one way. That will translate to A, correct? So I can safely write down 1 over here. So you might be getting an idea. If the test case was 0, 6, then the first number is 0, right? So it cannot be decoded. So this would have been a 0. Just give it a little while and you will understand. Now go ahead. You have to populate this particular value and look at the formula that we had. So we will take ways to decode at I minus 1 if this single digit is valid. 2 is valid, right? 2 maps to B. So I will do 1 plus of, this was the condition when I only took a single digit. Can I take last two digits? Yes, because 12 is valid. So we take up the I minus 2 value as well. That is 1. So 1 plus 1, that gives me a 2. And I'm going to write down 2 over here. So you see how we are populating this memoization array. Let us do the remaining iterations. For I equals to 3, I will first take up that, okay, is this single digit valid? This is valid. So I take up my last element, that is 2, and then plus of, I will now try to take up these last two numbers. It gives me a 22. 22 is also valid, right? It will map to some of the character. So then I have to add I minus 2th element as well. So 2 plus 1 and that gives me a 3. Move ahead now. This is where things get interesting. I have to populate this particular element now. So is this single digit valid? 0 is not valid, right? You cannot map it to any character. So we will not take up this value. But look at the last two values. Is 20 valid? So yes, this is a valid case. So how many ways to decode? That is I minus 2. So I will have just 2 ways over here. Moving on, once again I have to populate this value. So is 1 valid? 1 is valid. So I look up I minus 1th value and that is 2. So I get 2 plus, and then look at the last two digits, 0, 1. Is 0, 1 valid? No, right? Because the numbers cannot start from 0. So we will not take up the I minus 2th value. So I just get 2 over here. Move on to the last value and I will update this index. So is a single number valid? 6 is valid. So I take up this 2 plus, and then is 16 valid? 16 is also valid. So I take up this particular 2, that is I minus 2th element. So 2 plus 2 and that gives me a 4. So now my memoization array is complete. And remember, what did I tell you? This memoization array is telling me what is the total number of ways you can decode the string if the length is 6. So if the length is 6, the total number of ways to decode is 4. And that matches our decision tree exactly. So this memoization array is giving you the answer at every moment. If the sample test case had just been this 12201, then what was your answer? Your answer would have been 2. So based upon this approach, let us now quickly do a dry run of the code. On the left side of your screen, you will have the complete code to implement this solution. And on the right, once again, I have the same test case that is passed in as an input parameter to the function numDecodings. Now, going ahead with the dry run. What is the first thing that we do? First of all, we create our memoization array and then we initialize it. So if you remember, we initialize the 0th element with 1 because if your string is completely empty, then there is just one way to decode it, that you return an empty string, correct? And for the first index, you look, if your string has the first character as 0, then it is invalid and you will initialize it with 0. But if it is anything else, that means between 1 to 9, then you will initialize it with 1. Currently, the value is 1 over here, so I initialize it with 1 over here, right? So this is how I have set up things for memoization. The next part is simply iterating over the remaining string. So I start a for loop that begins from the second number and goes all the way up to the end. Correct? And at every instance, what do? I get both of my digits, 1 digit and 2 digit. So 1 digit will give me 2 and 2 digits are gonna give me 12. And now in the next steps, I just check if both of them are valid cases. So if 1 digit is valid, I add up this I minus 1th index, and if 2 digits are valid, I will add up this I minus 2th index as well. Currently, both of them are valid. So I will add 1 plus 1 and that will give me a 2 over here, right? This loop will now run once again, and this time I want to fill up this particular index. So once again, I will update 1 digit and 2 digit. So 1 digit will become 2 and 2 digit will become 22. Both of them are valid. So 2 plus 1, this array will update and it will become a 3. Quickly doing one more iteration, this loop runs once again and we have to update this value this time, right? So the 1 digit is a 0 and 2 digit is 20. So notice that 1 digit is not valid this time, right? So we do not add the I minus 1th value, but 2 digit is valid. So we will add the I minus 2th index. So I will just have 2 over here. So this is how this loop will continue running and you will have memoized all of the results. At the end, you want the total number of ways to decode your entire string. So you are simply gonna return this last element, which is telling you the total number of ways to decode a string of length 6, right? If you notice, we only traverse the array once, so the time complexity of this solution is order of n, and we are using our memoization array, so the space complexity of this solution is also order of n. I hope I was able to simplify the problem and its solution for you. As per my final thoughts, I just want to say that this problem is very similar to the problem of climbing stairs. Remember the problem where you are given a staircase and you can either take one step or 2 steps at a time. And then you have to determine how many different ways can you climb the staircase. This is so similar, right? You can either take 1 digit or 2 digit, and then you have to find out what are the total number of ways. The only difference is that this problem has a lot more restrictions. That means you can only have 26 characters, right? So these are the things that made this problem tricky. So I assume that once you solve more problems like this, you will start to see these patterns and then come up with a solution. While going throughout the video, did you face any problems? Or do you know any other method by which you can arrive at a solution even more easily? Can you find a solution that works in a constant space? Tell me everything in the comment section below and I would love to discuss all of it with you. As a reminder, if you found this video helpful, please do consider subscribing to my channel and share this video with your friends. This motivates me to make more and more such videos where I can simplify programming for you. Also, a huge shout out to all the members who support my channel. You guys really keep me going. And as a member, you do get priority reply to your comments as well. Stay tuned for my next video. Until then, see ya.